Welcome back to the arcade. Yes, it's that time. I'm going to finally tackle the bad pattern boards for the spare board sets in my Gorf. I have three pattern boards that are bad. This is the best out of the three. This is the one, if you watched my other videos when we were testing the pattern boards using the Bally Midway test cards, this is the one that almost worked. As you can see, it has some graphic glitches, but it does work in the game with the glitches. So I figured I'd start on this one right here. Now, I guess most would know by watching my other videos, I'm not an expert at repairing boards by any means. And I kind of have, I guess you could say, unorthodox methods of troubleshooting and trying to find out what's wrong. And I basically use what I call a common sense approach. And I don't have a whole lot of fancy equipment, but I make do with what I got. And most of the time I come out pretty good in the end. Now, I've always heard that these pattern boards are tough boards to diagnose and repair. Well, that may be so, but we're going to dig into it and see if we can't figure it out. Now, this board, since it's almost working, this may be harder to fix than a board that's not working at all, because if you got a board that's totally dead, which I do have one that when you put it in, it's just totally dead, that board might be easier to figure out what's going on, at least initially, to get the board up and running. It may have a lot of problems, because like I say, one of the board sets I had something happen evidently to the power supply in that board set, because one of the RAM boards had every RAM was bad except for one RAM. So that might be the pattern board that was in that particular board set, but we're not going to worry about that right now. We're going to focus on this one, and we're going to give it a try. And I sit down and try to think, well, how am I going to attack this? I'll put in the clip where we tested this pattern board in the board tester. And, well, I'll go ahead and put that in right now just to refresh your memory. Okay. Okay, well, this is giving me something different on this one. Now, 12, this one right here, board number 12, is it's bad, but the one that almost works. Okay, so we might have a chance at this. Okay, the data bus says it's okay. Okay, linear. Okay. Whatever that is, area LD, OK X wide, OK feed BK, 10 status, it says bad, 10 status, line, linear CT OK, area CT OK, adder OK, status flip flop, flush. Okay, that's a little bit different. Flop OK, flip bad, flash OK, whatever that is, CONS OK, EXP OK, and DR OK. So I got is that up top there to the right? Is that 10 status bad, or is that IO status bad? Okay. Here's the locations for those. It's data bus. Okay, that was okay. Everything is okay till I get to the, is that 10 or IO status? It just says status here. So that says U21. So that's, if that's bad, if I replace U21, I might have a winner there. All right, and flip is bad. Flip. That's pin 12 on U21. So again, U21. So I think if I replace U21 on this board, I'll be able to fix it. Okay, well, as you can see from that clip, this board came up with one error, and it said that the chip in U21, which is this chip right here, had a problem with the flip, I believe it was. I'm going off memory because I didn't just see the clip that you just seen. But I believe it was said check pin 12. Okay, well, I just went ahead and in that particular video, I just went ahead and replaced U21, the whole chip. I desoldered the old chip and I put it in my chip tester. The chip tester said that the chip I pulled out was good. I put a socket and put a new IC in it anyway. Retested the board and we still had the same exact problem. So now I know that U21 is not the problem. And I know that U21 is the only thing that I know about this board that I know is good, because that's a new chip. Okay, so first thing I thought about doing, well, let me get my logic probe out, and I'll probe the pins. And it had a list of error messages involving this chip. Pin 12 was one of them. And so I figured I'd go ahead and take my logic probe and probe each one of those pins. Now what I did, I put my good logic board in here that was working, and I went ahead and I used my logic probe. Here's my logic probe. And I checked each one of those pins, and I videoed what the logic probe was telling me, along with a picture of what the game was actually doing, so I could see, well, with the good board, I knew everything was working fine. Okay, well, I did that, then I put this bad board in, and I did the same thing. I checked each one of the pins, and I synced up the video on the screen with what I was doing on the board, and getting the information from the what the logic probe was telling me. Then I took it to my editor on my computer, and I put it all together into one video where you can see the original board being tested. At the same time, you could see the bad board being tested, so that you could see the logic probe on both of the tests and see what the logic probe was doing, and see if there was a, compare the two and see if there was a difference. If they did the exact same thing, then I'd know, hey, there's nothing wrong with that particular pin or the signal. But if they did something different, then that would give me a clue to say, hey, okay, something ain't right with that signal on that pin. So I went ahead and did that. So now you're going to see the video of me doing that. So U21, I test the I don't remember how many pins it was, but whatever pins it said to test when you had errors on U21. So let me cut to that clip, and you can watch that. And if you watch a little bit of it and you want to skip through it, that's fine. Then I'll come back and I'll tell you what happened after that. Okay, this is going to be a logic probe test. I have the Gorf card stack in the cage here, and I have it hooked up with a good pattern board. The pattern board is on the in the first slot here, and I got the brackets off, so I have full access to the top side of the board. So what I'm going to do is I have the logic probe hooked up to right here across the tantalum capacitor, which is the 5-volt line, and here's my logic probe. And what I'm going to do is I'm going to synchronize the two cameras, and because this is testing different than I thought it would, when I put the logic probe on the pins, it changes between the screens. So you have like the title screen, then you have Astro Blasters, then you have Laser Attack, then you have Galaxians, then you have Space Warp, and then you have the Flagship. Well, when you put the logic probe on one of the pins, you're testing a pin, each one of the screens, it does something different. So I can't use my original theory of taking the schematic and just probing the chip and marking down whether I'm getting a high or low or a high-low pulse signal, because it changes between the screens. And the bad pattern board is almost works on some of the screens, but some of the screens is really messed up. So in order to try to locate the fault, I'm going to have to get a sample of what each pin is doing on each one of the screens. So the only way to really do that, because unless I had two board sets side by side, you know, I can't test one board set and keep all that in my head and then put the other board set in, or the other pattern board in, and test that and say, yeah, this is doing what the other one did, or it's not doing. So I'm going to have to make a video of each one and then compare the two videos and see if I can find where the signal differs, if that makes sense. So anyway, I mean, I could just probe to see if it has signals, and then if one of them doesn't have a signal, if one is high or stuck high or low, yeah, that could be the fault. But it may be that the chip is kind of working, but it's not working exactly correctly. So I think this would be the best approach. So anyway, I'll wait for the next cycle, and according to the when we tested the board on the board tester for the pattern board tester, it said it had a problem with U21 on the bad board, but we changed U21, so it couldn't have been U21 was the problem. But anyway, I still want to look at U21 on both boards and see if I'm getting the same signal on both of them. So that's what we're going to do here. Okay, so I'm going to start off with pin 12, which is the flip. and it was saying that the flip was bad. So that's the one I'm going to start off with. But actually, I might go and do all of the errors on that. Pin 15 is the flop, pin 12 is the flip, pin 10 is the flush, pin 7 is the constant, pin 5 is the expand, and pin 2 is the direction. So let's go down in order. Let's start with pin 15. U21, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Okay. Oh, messed up. All right, on the title screen, it appears to be high. This is pin 15. Okay, that was high. Still high, no change. Still high. Still high. I just let it slip off. Still high. So pin 15 is high all the time. All right, so let's go to 12. Here's pin 12. And this is the title screen. It's low right now. So all doing this is low. All right, now you get some activity. And you can see, all right, this screen is low, but it will start. There you go. So it should be like a signature for each one. Okay, when it gets back to this, it's low. All right, let's go to pin 10. Okay, this is pin 10. Again, it's low on the title screen here. Okay, now it's high on this one. Keeps flipping back from high to low, high pulse low, when it flips and changes screens. Interesting. This is pin 10. That's called flush. Okay, now it's going back to low on the title screen. All right, pin 7. Okay. Pin 7 is high so far on the title screen here. Okay. It's kind of doing the same thing. It's kind of changing states when it changes screens. Okay, back to the title screen. That was 7. Now we're going to do 5. Okay, 5 is low, and then it gives a high pulse during this title screen part. Okay. Doing pretty much the same thing though. Changing states when it changes screens. Okay, next we're going to do pin 2. Okay, there's pin 2. We're on the title screen. Okay. A little different. Pretty much staying low most of the time. Okay. Well, that's it. Only 6 pins that it says to test. Of course, there's more pins than that on the chip, but they're the main signals. So I'm going to review the video, and if I don't see any difference between the two boards, then I'm going to have to dig a little deeper and maybe do the same thing with all the other pins. And if I don't see any difference, then I already know changing the chip didn't change anything. So I'm going to have to start looking at the chips that connect to this chip that or that this chip controls. I don't really know what this chip does, so yeah, I'm gonna have to look all that up. I got it written down here somewhere, but this chip is a a 74LS174. So this is a hex D type flip-flop. The LS174 contains 6 flip-flops with single rail outputs. Okay. All right. I'm going to end this video and do a little research, and I'll be back. Okay, well, as you can see by watching the video, one thing I noticed was the only thing I changed between the two videos when testing was the pattern board. All the other boards remained the same. And I noticed that, let's see, I'd have to look at the video to get it which way it really is, but I think the bad board caused they're programmed to lag. In other words, when I synced up the videos, I started them at the same time, but the one with the good pattern board finished before the one with the bad pattern board. Now, I don't know why, because both of them uses, as far as I know, the clock from the MPU board. So if it was something to do with the clock signal being a different speed, I don't know why it would be that way. But maybe that's not a big deal, but it might be that, well, whatever's wrong with this board is causing the board to slow down a little bit. That's possible. When we fix the board, and I am going to fix this board one way or the other, I'll have to go back and test it and see if it still lags behind the other board. Okay, well, anyway, as you can see with that test, everything looked normal between the good pattern board and this almost working pattern board. All the signals seem to check out. So where do I go from there? Okay, well, I got thinking about it, and I figured I'd look at the schematics first. Okay, and here's U21, the status, the chip that does the status. And so I figured what I would do first is, the tester said it was a problem with pin 12. So I figured I'd follow pin 12 and follow it all the way down, and it went to U23. So I figured I'd take the probe and I'd probe around U23, and I did, and I didn't see anything that stuck out as being wrong. So then I looked at all the other pins that go to U21, and I followed them all over the schematic. Wherever they went, I went to that chip, and I used the logic probe, and I couldn't find anything that seemed like was wrong. So I said, well, this ain't working. So then I thought about it. I said, well, looking at what the game is doing here, I thought about, well, maybe I need to narrow it down and try to figure out what was going on. Because there are different sections on the board. You know, you have your linear, you have a data bus, you have an area counter, you have a feedback section, you have an area load, and you have X wide. Okay, so I figured like the linear section might deal with linear motion on the screen, and the X wide would have to do with, you know, moving objects, and, you know, the different areas would do different things. So then I decided, I said, well, let me try something that I've never tried before. Okay, well, I've had this logic probe here for probably 20 years, and it's been a good one. I really like the form factor. I like that it has a red LED for the high, a green LED for the low, and a yellow for the pulse. And it also has PCO speaker in it so that you can hear audio. Okay, as you can hear, so it makes noise so you can hear what the circuit sounds like. Okay, well, about a month ago, I decided I needed something to go along with the logic probe. I got a logic pulser. Okay, now I haven't seen a whole lot of people talk about a logic pulser, and I haven't seen a whole lot of people use one to troubleshoot with. But I have seen a couple videos on YouTube. It's one in particular where somebody explained how it worked, and I kind of get to grasp the idea of how it works. It has basically two settings here. It's got a 0.5 pps and a 400 pps. Okay, I think what pps stands for is pulses per second. So when you got it down into 0.5, you see the little LED, it blinks real slow. Every time it blinks, it sends out a pulse, okay? A digital pulse. And when you put it into the 400 pps, it looks like it's on solid, but it's actually sending out pulses real fast. Okay, now, my basic understanding of how this works is, if you got an IC that has an input and it also has an output, corresponding output. Well, if you want to check to see if the input and the output of that chip is working, you can take your logic probe and put it on the output of the chip. You take your pulser and put it on the input of the chip, and when that pulse pulses the input, the signal will go through the chip and you'll be able to see it on the logic probe. So you'll know that the input and the output on the chip is working. Okay, now pretend like I'm putting this on a chip, on the pulser on the input of the chip and the logic probe on the output of the chip. But what I'm going to do is I'm just going to touch them together. Now, first let me put it down in the slow pulse here. And let me touch them together. And every time the pulsar pulses, you'll see the logic probe receives the pulse. Okay? All right, now let me put it up on 400 pps. Now watch it. Okay? So you can inject that pulse into the chip and see what the output is. Okay? Well, I got the bright idea. What if I take the pulsar and I just go down each one of these chips? Of course, not just willy-nilly. I look at it. I can start with U21, and I'll put the pulsar on U21 and observe what happens on the screen. That way I can tell, all right, well, that chip, you know, if it makes something happen on the screen, I can kind of say, all right, well, that pin is connected to whatever it's doing on the screen. If that makes sense. It made sense in my head. So let me just try that a little bit, and let me see if I can show a little bit of it here. All right, I'm not going to show putting the pulsar on the chip. Just watch the screen right there, and we'll see what it does. Now I'm gonna do U21. Okay. I'll put it on pin 1. And pin 1 just makes it reset. Okay. Pin 2. All right. See what pin 2 is doing to it. All right. Pin 3. Pin 3 made it reset. When it resets to that screen, you have to cut it off and start it back up again. All right, pin 4 resets it. Pin 5, okay, it's making those lines. Pin 6, reset it. All right, pin 7, okay, making more lines. Pin 8 doesn't seem to be doing anything. Pin 8 might be ground. I don't know. All right, pin 9. Okay. Pin 10. All right, see, pin 10 is making the streaks behind the objects. Pin 11, I think pin 11 reset it. Pin 12, this is the pin that supposedly had a problem. All right, it's causing those streaks. Okay. All right, pin 13. It caused a reset. Pin 14 caused a reset. Pin 15. Look at those crazy lines. And pin 16. Okay, I don't see nothing on 16 right now. Let it change to another screen. Yeah, 16's not having any effect on it. Okay, so that's basically what I decided to do. And what I did was I followed all the paths from that chip U21, and I went to all the other chips, and I started doing this with the logic pulsar until I found one that looked like it enhanced the goofiness, if that makes sense. You know, what was happening on the screen, I found something that looked like it was in the area and kind of doing what it was doing. So once I found the general area, okay, and the general area, it seemed like the chips in this area right here in the feedback section, that seemed to have the most effect on what it was doing. So what I started to do next is the old piggyback trick. I started taking the chips, and I'd get a chip that was just, you know, the right chip, and I would piggyback it on top of chip on the board, and I would see if it had any effect on it. And most of the time when I put them on there, it had no effect at all until I got to one chip. And this chip right here, U38. Put U38 on there. Let me show you what happens. Okay, U38 is an MC14008. Okay, that's the chip. So I'm going to cut it off here, and I'm going to piggyback it right on top of the chip. Now, this isn't easy to get on here sometimes. And it has to be just right or it's not going to work. Okay. Let's see if that works. Okay. You can see right here, I piggybacked the chip on top of the chip. So let's turn it on. Nope, not yet. Like I say, it's finicky. You have to get it just right. You gotta get all these pins to line up. Okay. Nope, not yet. All right, now it's going to make a liar out of me. Okay. I finally got it on there. Like I say, it's real tricky. And you got to get it on there just right so that all the legs are touching. So let's turn it on. And looky there. The board is fixed. Now this little piggyback of chips, I know a lot of people says, oh, you can't do that, it don't work, blah, 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 blah. Well, a lot of times it doesn't work, but there are times that it does, and it doesn't hurt nothing to try it, and never know, you might get a winner, just like we got right here. Winner, winner, chicken dinner. There we go. And it is working perfect. Okay, so, all right, well, next I wanted to figure out, well, what pin on that chip is bad. I tested it with the logic probe, and everything looks fine. You know, all the signals look good, and I really can't find nothing wrong with it using the logic probe. So I decided, well, let me get my old scope out and hook it up and just see if it will show anything, you know. And I did. I got it out. There it is right there, and it's an old analog scope, an old B&K 1535A 35 megahertz scope, and it wouldn't do nothing. I couldn't get it to do nothing. Now it works okay for hooking up to a vector output board to, you know, use as a vector monitor while you're troubleshooting a vector game, but that's about all it does. So I guess I need to invest in a good scope. So if anybody has any recommendations, leave them in the comment. What kind of scope would you use for looking at the inputs and outputs of these chips? Should I get a more modern digital scope for that? Or could I get a better analog scope? You know, which would be the best? So, yeah, just leave a comment and let me know. Okay, well, I still had curiosity, and I wanted to know, you know, what was bad with that chip? So I got to thinking, I said, how can I do this? How can I figure it out? So what I decided to do is I took another chip and I figured I looked at the schematic here, and I thought that since the signal from U21, which was supposed to be where the problem was, it comes down through here and sort of gets in this area right here. I thought, well, maybe it would be on one of these 4 pins right here. Pin 10, pin 11, pin 12, or pin 13. So what I did was I took the chip here and see if you can tell. See, I bent the leg out. So I put the chip on piggyback with a leg bent out, not making contact. So first I tried pin 10, no change. It still worked. Then I tried pin 11, no change. It still worked. Pin 12, no change. It still worked. Pin 13, no change. The board was still working. So then I looked and I said, well, would it be one of these over here? And I said, well, what's this one right here? And you can see I got it circled. That's pin 14. I said, well, let me try that. So I bent pin 14 out, and that's what's been out right here, pin 14. Okay. Well, I put that chip on, piggyback, and guess what? Bingo. That is the bad pin, or where the signal is bad, that's not working. And what I did was I put this chip on piggyback, and with that pin bent up, it went back to not working. And then I took my logic probe and I put the logic probe on the pin that I bent out and touched it, and then touched the pin on the chip to make a connection, and then all of a sudden, bam, it started working again. So I've confirmed that that's the pin that's causing the problem. Pin 14 on U38. Okay, so that wasn't so bad now, was it? Now what you didn't see, the last couple nights I've been spending an hour or two out here doing all this stuff. So I got maybe total about 3 hours invested in looking over this board and trying to figure out what's wrong with it and try to trace down the problem. And so that's not bad. I mean, it's not good, but for somebody like me that's not really an experienced board repairer, I think that's pretty good. I just used basic common sense to try to hunt down the problem, and I systematically, went through the schematic, and I never did get down to the level, and I thought I was going to have to at one point. I'd already took all these ICs that's on this board and printed out the data sheets on them and everything. So worst come to worst, I was going to get the data sheets out and start going through each one of the chips and trying to do a more thorough investigation of, depending on what the chip is, if the chip did have a input and an output, to check to see if the input and the output is working and all that good stuff. So, yeah. All right, well, we still got one more thing to do. I got to get my desoldering station out and my soldering station, and we got to pull that chip and put a socket in and put a new chip in there and then test it again, because you never know it might work with that chip piggybacked, but if I take that chip out and replace it and put one in it, it's possible it could still have a problem. You know, this chip might be, you know, affecting another chip that might actually be bad, but with that chip piggybacked on it, it might be pulling it so it's good. So, hey, things happen like that sometimes, but I don't anticipate any problem. I'm thinking that if I replace that, I'm going to be good because, yeah, it's rock solid right now. All right. Well, let me get to doing that, and I'll be right back. Okay. Well, I've got the chip out, put a socket in, and we've got a brand new chip installed on the board. All right. Is it going to work? All right. Well, let's turn it on and find out. Looks good to me. Of course, we'll have to let it run through the whole track mode there. And looking good. Don't see anything that doesn't supposed to be there. All looks like it's working. There we go. And I say we have a success. I would call that a success. Okay, well, that wasn't too bad. I mean, I was looking for more of a fight than what it was, even though, you know, it's a little frustrating sometimes when you keep checking stuff and you don't find anything wrong. And even when I knew the pin that was wrong, I still couldn't tell it was bad. I guess if I had a good scope, maybe I could have seen that there had to be some type of a interference on that line or something that wasn't right that was just causing that the problem there. But I couldn't see it, you know, using a logic probe. But I believe that if you're like me and you do this sort of this type of troubleshooting where you don't have all the big fancy equipment and the scopes and logic comparators and all that stuff, yeah, get yourself a logic pulsar and go through the chips with that. If you have a working game, I mean, it's not going to work if you don't have a working game, but you can still use the pulsar to check the, you know, put it on the input and then use your logic probe to check the output. So I'd say it's a tool that's worth having. Some people might not think so or might not use it, but in this particular instance, I found it very useful, and it actually kind of led me to the right part of the board by, you know, using it on the chips and observing what was on the screen so it could kind of know when I was in the area that was affecting the areas that were messing up, where the problem was. So in a way, it worked out for me anyway. So maybe your mileage will vary, but give it a try. You know, if what do you got to lose? All right. Well, 1 down and 2 to go. Anybody want to make bets? Are the other 2 boards going to be more of a challenge now that I have a kind of a troubleshooting technique. One of the other boards does, you know, will boot up and puts a, you know, you get a video on the screen, so I may be able to use that same technique on that one. Now the last board, the third board, it doesn't even boot up at all, so that might be a little bit more of a challenge, but then again, it might be easier. Just have to wait and see. Okay. All right. Well, this video's over. If you like what I'm doing and you enjoyed the little stuff that I go through to fix this stuff, be sure to subscribe to the channel. It'll help the channel out. And never going to be as big as the big boys, but, you know, trying to get a few more subscribers and build the channel up a little more. And if you do, you'll be notified when I release my next video, because I don't have a set schedule when I come out with a video. You know, it just, you know, whenever time allows me to get out here and work on stuff, and then I decide what I'm going to do. And sometimes I feel like filming, and sometimes I might not feel like filming. So, you know, I might just do a few things just to get them done, you know, because when you film this stuff, if you've never done it, it does take time to set up the shots. You have to set up your lighting, you know, you have to think about what you're going to do and what you're going to say, and I'm no expert on any of that, so, you know, just going by the seat of my pants, but it seems to be working out so far. So okay, well, that's it for this video, and till next time, this has just been an arcade fix. Have you had your arcade fix today?